All right, guys, we are going to get started. Um, how did it go with Ryan? Louder, I can't hear you guys. Was it good? Was it boring? Did you go through the rules today? Did you guys do any two passages? How many passages?
It was from the reading and writing.
Okay, just one passage or something like that? Okay. Okay. But did the rules help you? What we are, what I can guarantee, guys, is if you don't know the rules, grammar rules correctly, you will apply it the wrong way in the real test. Knowing these rules, did he write it or did he talk about it? What did he do? He wrote it on the board. Okay, good. The next thing is homework. You're supposed to be done with week 1 and week 2 homework. Have you guys done that? How about online students? Have you done the homework?
Yeah.
Okay, quite a bit of thumbs up. Anybody who have not done the homework? Okay. All right. Let me quickly read your names: Josh, Peyton, Ava, Trinity, James,
Here.
Samuel,
Here.
Braden,
Here.
Sophie, Marin,
Here.
Eli,
Here.
Max, Kate,
Here.
Tyra, Carson, Lucas Hemingstead,
Here.
Lucas Huser,
Here.
Chase,
Here.
Mac, Mac Drake, okay. All right. So this week, the week 3 homework will be due. Okay. So it just keeps going on. So we have done 1 session of math, 2 sessions of reading, and 1 session of English so far. Okay. Go ahead and open your notes for math. What we did last time. We did straight line equations. We did a whole lot of it. Do you guys remember that? It's a big chunk in your ACT. Now in the math packet, please open page 14. I'm going to give you guys 5 minutes to read page 14. From this page, you may get that 1 question in the ACT. Average has been 1 question. All right. Usually they give you regular convex polygon. Usually I've hardly seen anything with concave polygon. Okay, so that's usually the standard. And there are three formulas you have seen there. One is the interior angle, one is the exterior angle, and one is the number of diagonals. You have to know these equations. So if you have a highlighter that was given to you guys in the packet, go and highlight those three equations. I, E, and the number of diagonals. Those are the three you'll be expected to know, because if you don't know the formulas, it's going to be very hard for you guys to do those problems. All right, let's get started. First question. Okay. Find the interior, exterior, angles and number of diagonals, total number of diagonals in a heptagon. And you're supposed to know these terms too. So heptagon is how many sides? Come on. 7. 7. What's 4? Quadrilateral. 5. Pentagon. 6. Hexagon. 7. Heptagon. 8.
Octagon.
That's your stop sign is an octagon. 9. Nonagon. 10.
Decagon.
Decagon. 11. Undecagon. 12.
Dodecagon.
Dodecagon. So 11 is undecagon. So you have to know till 12. Go ahead and try this problem. Find the interior, exterior, and total number of diagonals of a heptagon. All right. So this is an heptagon. Could have drawn better, but this is your interior angle, I. So for each point there is one interior angle. So heptagon has 7 sides, 7 vertices, 7 interior angles, and 7 exterior angles. And this is your exterior angle, which is outside this part. The first thing you could immediately see that the I plus C always adds up to 180. Okay. Okay, something to remember. For a convex regular polygon, the sum of the interior and the exterior adds up to 180. So I is equal to n minus 2 times 180 divided by n. So 7 minus 2 times 180 divided by 7. What do you guys got? Come on, guys. Let's not waste time. 120.
8.6.
Okay, let's not waste time. So what will be the exterior angle? You can either use the formula or just do 180 degrees minus 128.6. How much it comes out to? 51.4 degrees. Or you can use the formula 360 degrees divided by the number of sides. Number of diagonals is n minus 3 times n minus 3 divided by 2. 7 times 7 minus 3 divided by 2. What is that? 24, 28, 14. Make sense? Yeah, this will only work out if you know the formula. If you don't, doesn't matter how smart you are, it's not going to cut it. Am I right? You can stare at the question all you want. It's not going to make any difference there. So, plain and simple. If you know the formulas, you can at least go to the next step. If you don't know the formulas, staring at the question will not get you an answer. You're actually just going to waste your time. Sounds good? Plain and simple. Next question. This is an important one. Put a star mark to this one. And this is exactly how it was written in the ACT. This was question number 44. This is all it was written in the test. All right. I would like anybody to tell me your answer. Anybody? Go. Go and say with the online students. If you have an answer, go ahead. No one? It doesn't matter if it's right or wrong. I really don't care. What I care is
292.5.
292.5. Okay. Anybody else? Okay. All right. There's enough. There's two ways to do this problem. So let me go with the first method. So this is my interior angle. Do you guys agree? So this is an octagon. I is equal to 8 minus 2 times 180 divided by 8. What do you guys get? Somebody do that.
135.
So 135 degrees. If this is 135 and this point forms a circle here, you can see that, right? And circle is how many degrees? 360. So x should be equal to 360 minus 135, which is 225 degrees. Right? That's method 1. Method 2 is, you got to listen to this. So this is the straight line here, and I'm going to extend this line. I'm going to extend this line. What is this angle called? Exterior angle. And what is this angle? Straight line. 180. So x should be equal to 180 plus the e. Am I right? So what's e? 360 degrees divided by number of sides, which is 8, which is 45 degrees. So x is equal to 180 plus 45 is 225 degrees. Make sense? It's up to you which method you would like to do, whatever you're comfortable with. But boy, you should know these. Okay. Good? So we did page 7, page 14. Go to page 6, please. Another huge topic for you guys. Significant. Circles. Then I'll give you, so we'll be studying circles, just circles today, okay? Take 2 minutes to read through it, please. That's good. Circumference is 2 pi r, radius, area is pi r square, right? You guys know all these things. First question. So if you have two circles with the same center point but different radius like this, these are called concentric circles. These are called concentric circles. So two different radii but the same center point. So this, let's call this as 12 centimeters, and let's call this one 14 centimeters. Question to you guys, first question. Find the area of the shaded region. Find the area of the shaded region. Probably seen it almost every single time in ACT or pretty close to it. Yeah,
You said the area, right?
the area of the shaded region, yes. Usually you can expect this question around somewhere around 35-ish is what you can expect. All right, let's get started. So we have two concentric circles and looking for a shaded region here. So imagine a big circle and you cut a circle off and whatever is remaining is that one, right? So what you do is you take the area of the big circle, which is pi 14 square, this is the big circle, and you cut the small circle off of it, pi 12 square. That's your answer. So 14 squared is 196 pi minus 144 pi, so it is 52 pi. And guess what? This is how exactly they will write in the ACT. Yeah, you can do 52 times 3.14. That's all fine. But this is actually how they prefer in ACT. How many got this? 1, 2. Anybody online who got this? Okay, few people. All right, next question. Let me first draw this, then you guys can write this out. So, we have a circle inscribed, a circle inscribed in a square with the radius 10 centimeters as shown you have to find the area of this region. This region, you have to find the area of this region. Go. Anybody, an answer? Right, wrong, doesn't matter. Your participation is more important.
100 minus 25 pi.
100 minus 25 pi, okay? Next. All right. So we have the circle. So you can take a square. How do you know it's a square? Well, the radius is 10, so this is 10, and this is also going to be 10, so this will be 20. If this is 20, this is going to be 10, this is going to be 10, so this is also going to be 20. Right? So you have a square, so the area of the square is 20 squared, which is 400. Then you cut a circle out of it. So the area of the circle is pi r squared, which is 100 pi. Then, so what are we left after the circle is cut through it? You're left with this piece, this piece, this piece, and this piece. Am I right? But I only need one piece. So the shaded area is equal to 400 minus 100 pi divided by 4, because I need only one piece, which is 100 minus 25 pi. Yep, you're correct. I didn't realize it was 10 centimeters. I thought it was 5. So, does this make sense? This would be around question number 40. Between 35 and 40, I would say. Good? Okay. Question number 3. What is this line called? Come on, you guys need to know this. Anybody online? Can you tell me what is this line called? Yeah?
Isn't it a sector?
Nope. Come on, this is easy. How about I give you a hint? It starts with a C. It ends with a chord. Come on, guys. You've heard chord, right? Yeah, I expected this. Which is the longest chord of a circle?
The diameter.
The diameter. Thank you. Right? If I move this to the center point, it becomes a diameter. So the longest chord is called a diameter. You guys need to know this. A line drawn at 90 degrees to a chord from the center point bisects the chord, called perpendicular bisector of a chord. Very, 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 very important. Sounds good? What's the advantage of this? Now you have a right angle, and what happens here? What is this distance called? Huh? Yeah, hypotenuse in the triangle, but when compared to the circle, what is this dotted line called? Radius. So you can find a radius using a chord. Using the 90, the hypotenuse, the Pythagorean. Sounds good? So the chord is extremely important in circles. I know you guys don't know or maybe forgotten. It's something you guys need to take it very seriously. Sounds good? Okay. So this distance is 24. This distance is 5. Find the circumference of the circle. Find the circumference. Expect this question around 45-ish. Okay. So if the whole chord is 24, the chord gets bisected by the straight line 5, so it becomes 12 and 12, So 5, 12, and radius becomes 13 because 5, 12, 13 is a Pythagorean triplet. Or you can do a squared plus b squared is equal to c squared, which will of course takes more time. It eats away the time. Knowing 3, 4, 5, 5, 12, 13 would help you a lot. So if the radius is 13, circumference is 2 pi r. So 2 pi times 13, 26 pi. How many got 26 pi? A few people. Anybody online get 26 pi? Few people. Okay. All right. Any questions so far? You guys getting this? Okay. I'll give you 2 minutes to review what we just did on this whiteboard. Go ahead. Just 2 minutes. Especially question number 3 is important. All right, so just a quick update on the plans for the next. We're not done, by the way. Just a quick. Next week I'll be doing science, and Aubrey will start with math again. Continue with math again. So next week science is going to be extremely important for you guys, especially many of you are hearing some of the strategies we use for the first time. So you don't want to miss next week class. Okay, pretty crucial. All right, so we did the pages 6, 7, and 14, which are very, very important. Go to page 15. At the bottom of page 15 is a number line. I'm going to give you guys 2 minutes to review page 15, absolute value inequalities and numbered lines. Some of these questions can be very tough in ACT, by the way. So if you don't know this stuff correctly, this can be a surprise for many. number line. We're gonna start with the easy one, and then we're gonna start building on it. We're gonna do a bunch of these, but start with a very simple one. Draw the number line for absolute of x is equal to 4. Simple. You won't get this question in the test, let me tell you that. Just a good build up. Done? Remember, what does absolute does? Absolute measures distance. Distance is always positive. So absolute of x is equal to 4, which is positive. Absolute cannot be negative. But when I break the absolute, x can be 4 or negative 4. So number line 4, negative 4. This is your number line. You will not get this question in the test, I can guarantee this. Okay. The next, you may get this question. Absolute of x is greater than 4. All right, so when you have a greater than or a less than for an absolute function, you want to be a little careful. So what it means is if I put a value of x, the absolute value of that must be greater than 4. So if I put 5, absolute value of 5 is 5, 5 is greater than 4. So it's good. Let's say we put absolute value, we put x is equal to negative 6. Absolute value of negative 6 is 6. 6 is greater than 4. So when you have a greater than function, when you remove the absolute sign, x is greater than 4, or this is called an OR function for that reason, x is less than negative 4. This is the key thing to remember here. So number line, and of course it's not equal to, so you use a hollow circle, which you guys know, greater than 4, less than 4. Make sense? Same problem, absolute of x is less than 4. a less than absolute function is called an AND function. So when you have less than 4, so it's saying whatever is the value of x, it should be less than 4. 0 is less than 4, 1 is less than 4. So we have limited values of x that is less than 4. So minus 4 is less than x less than 4. So the x is between negative 4 and 4, where it's, if we take the absolute value of it, it still is less than 4. Make sense? So the number line is 4, negative 4. So first of all, it's a hollow circle, and then you shade it here. Anything absolute in that region will be less than 4. Make sense? I would put a star mark to this one. I've seen people make mistake in this one. Question before. Draw the number line. This is first chapter of Algebra 2, by the way. This is what they're teaching, first chapter. Okay. The first thing I've seen students do with this problem, as soon as they see this, oh, it's is equal to negative, this cannot be done. That's not true, because the absolute has something else with it outside. So plus 4, both sides. Plus 4, both sides. So absolute of 2x minus 4 is equal to positive 3. Now we can make addition. If this was still negative, then there's no solution, because absolute cannot be negative. But now it's positive, you can do the problem. So 2x minus 4 is equal to 3, or 2x minus 4 is equal to negative 3 when we break the absolute sign. Make sense? One thing I want to tell you guys to be careful with absolute functions. When you get an answer, doesn't matter one solution or two solutions or more than that, at least plug a value back into the equation and make sure it works out. Okay? So for example, if we get 7 or a half, I would just, let's try this here. I put the original equation. 2 times half is 1. 1 minus 4 is negative 3. Absolute of negative 3 is 3. 3 minus 4 is negative 1. So you always test your solution. You will be surprised sometimes. Just because you got an answer doesn't mean it's actually a true solution. These are sometimes called false solutions, and it happens quite a bit. Sounds good? All right. So, online students, continue to do the homework. Next week is very important. Don't miss classes, and I'll see you guys next week. Okay? Bye. See you.